For number 1, you need to figure out if it is a linear relationship, and if it is linear, we can find the rate of change. So remember, we're trying to find the change in y over the change in x, and it needs to be consistent. So 64 to 16 is a big number, but I'm going to start with these smaller ones. 64 to 4 is minus, or 16 to 4 is minus 12. 4 to 1 is minus 3. 0 to 1 would be plus 1. 0 to 2 is plus 1. So if I think about my rate of change, is this consistent? It's y over x, y over x. So negative 12 over 1 is negative 12. And negative 3 over 1 is negative 3. These are different numbers, and because of that, this is nonlinear. When it's nonlinear, remember, we don't have a rate of change. Let's look at B. Negative 6 to 4 is plus 2. Negative 4 to 2 is plus 2. I'm seeing my y's are changing consistently, so let's make sure my x changed consistently too. We have plus 1 the whole way. So because no matter what I divide, whenever I do the y by x, in every case, the y is 2, the x is 1. So it's linear, and y over x is 2 over 1, which reduces to 2 for the rate of change. Number 2 asks us to graph. Remember, we can look at the equation and know right away whether it's going to be linear or nonlinear. Because this has a power of 2, I know this is going to be a nonlinear graph. We also talked about how something that's a squared number is going to be a U shape. So if I don't see that full U shape after making my table and plotting it, I need to continue to add points. So let's say I chose 0, 1, 2, and 3. Remember, after we choose whatever points we want for x, we plug them into our function that we are given. So I would say 0 squared plus 2 is 2. 1 squared plus 2 is 3. 2 squared plus 2 is 6. 3 squared plus 2 is 11. So when I graph this, I have 0, 2, 1, 3, 2, 6, and then 3, 11 doesn't fit. But when I connect my dots, this is not a U shape. So I need to choose additional x points. So even though I filled the table, I did what it said, I don't see this shape here because I know it's nonlinear. So I need to continue by choosing some negative values. So let's plug in negative 1 and negative 2. So we need to extend my table. So negative 1 squared plus 2. Negative 1 times negative 1 is 1. 1 plus 2 is 3. Negative 2 squared is 4 plus 2 is 6. So we have negative 1, 3, negative 2, 6. And now when I connect my dots, I see that full U shape of my graph. Make sure you see the full shape. Here's another graphing problem. So just by looking at my equation, because this is a single x, I know this is going to be linear. So this is my graph. It is linear. It is a positive slope, so I know it's going to go up. And so I can choose any values I want. We'll say negative 2, negative 1, 0, 1, and 2, just like we talked about in class. And then we're simply plugging in these values. So 1/3 times negative 2 plus 1. So this is negative 2/3 plus 1, which is 1/3. Now, this is not a very nice number. So here's what my actual hint is. Because when we have this 1/3, it doesn't have a nice value. So we actually can choose different x values that are going to benefit us more. So looking up here, I want to choose anything that's divisible by 3. So I could choose negative 3, 0, positive 3, and 6. And that's just going to give me nicer outputs or nicer y values. You could choose the other numbers we started with the first time. This is just going to give me something that's not a fraction. So I have 1/3 times negative 3 plus 1. Well, these 3's reduce, so it's just negative 1 plus 1, which is 0. 1/3 times 0 plus 1, well, 0 plus 1 is 1. 1/3 times 3 plus 1. 3 is reduced, so this is 1 plus 1, which is 2. And 1/3 times 6 plus 1. This reduces to become a 2. 2 plus 1 is 3. So just by choosing things that were multiples of my denominator, it gave me a better table, but anything would technically work. This way though, I got all whole numbers for my y's. So -3, 0, 0, 1, 3, 2, and 6, 3. And then remember, we connect them in a nice straight line, put those arrows on the end, and we have our graph. For the next 3 problems, we're given different representations, and from these different representations, we need to go ahead and write the equation. So starting with the graph, we can look and we can clearly see the y-intercept is right here at the point 0, 3. I have another point right here, so I can find the slope, rise over run. So we went down 2 over 3. So we get y equals -2/3 x. Y-intercept is +3. So from a graph, that's nice and easy. From our table, we're looking for the slope and the y-intercept. So slope we can calculate, so that's a change of down 2. X's are changing by adding 4. So to find the slope, it's y over x. So -2 over 4, which is -1/2. So we have y equals -1/2 x. But now I have to figure out what is the y-intercept. Y-intercept is when x is 0, which would be right here. That's directly between -2 and +2. So I'm just looking for the number directly between 4 and 2, which is 3. Right here is my y-intercept at +3. So there's my equation. And last but not least, we have a word problem. Mary purchased a sunflower at the garden store to plant in her backyard. When she brought the plant home, it was 3 inches tall. The plant grew at a constant rate of 2 inches a day. How tall will the plant be in 30 days? So when we think about this, it's actually 2 ordered pairs. When she brought it home, it was 3 inches tall. That's the point 0, 3. It grows at a rate, so this is my M, of 2 inches per day. So from this information already, I can write my equation. Y equals mx plus b, 2x plus 3. But then we have a question. How tall will the plant be in 30 days? So we don't want 11 years. We want 30 days. And so all we're going to do is plug in 30 for x. 2 times 30 plus 3 will give me my height. So 2 times 30 is 60 plus 3, it's 63. Now if it asked after 1 year, remember we're talking about days and inches. So if we want to know the height after 1 year, we would have to think of that as 365 days, and then that's the number we would plug in. We wouldn't plug in 1 because my x values are days, not years. So making sure those labels are consistent is going to be really important. But after 30 days, we know my plant will be 63 inches tall.